Hello, sorry I couldn't be here today with you. But let's talk about evaluating polynomial functions. So you should have all gotten this sheet handed out to you on this tab. It says 5.2, evaluating polynomial functions. And it starts with talking about the definition of a polynomial function. So this looks kind of confusing, right? F of x equals a sub n x to the n plus a sub n minus 1 to the x all the way down to a sub 1 x and a. So all of the a with the sub n's or the sub n minus 1s, those are all your coefficients. Okay? And then all of the exponents, your n's, are your exponents. So the definition here we have is they have to have real coefficients, meaning there can't be imaginary number coefficients, okay? And then they also have to have positive and whole number exponents. So we can't have any like square roots because that's of an exponent of 1/2. But we're looking specifically only at the one with an x, right? We're not really concerned with the a sub o, which is our constant at the end. So all of our exponents for our x values have to be positive in whole numbers. And then the last thing is that a sub n can't be 0. So your very first one, your leading coefficient, can't be 0. So let's take a look at some examples. Here we have f of x equals 3x plus 2 minus 2. Let's check and see. Well, real coefficients, yep, 3 is definitely a real number. And positive whole number exponents, well, this has an exponent of 1, right? And so yes, that's a positive whole number exponent. Okay, let's move on to the next one. Here I have real numbers. So my coefficients are real numbers, and my exponents are 2 and 1. They're positive whole numbers. We're good. Same thing here. Real number, and I've got 4 and 2 as positive whole number exponents. Non-examples. Okay, I have x squared plus 3, and it's all under the radical. The important part here is that the x squared, really it's the whole thing. It's the x plus 3 is all under the radical, and it joins them together. And we can't have that because that kind of gives us a strange non-positive whole number exponent. Okay? On this one, we have g of x equals 1 over x. Well, we just learned about exponent properties, so I could really write this as g of x equals x to the negative 1. Because remember, like Snoop says, you got to drop it like it's hot when it's negative. So that means if you have an x in the bottom of a fraction, it has a negative exponent, and therefore it's not a polynomial. And then the third one, we look here, we've got two things that are not good. The first one is a fractional exponent, which we can't have, and the second one is a negative exponent, which we can't have. So none of those are polynomials. Okay, take a moment to soak it in, and let's go on to the chart. So this chart is going to help you tell or give the type of a degree of a standard, the polynomial in standard form. So degree talks about the highest exponent in that polynomial. So if we have a degree of 0, that means all I have is a constant. And here's an example, right? I have f of x equals negative 14. Negative 14 is really the only thing. It's a straight line, right? It's a horizontal line going through negative 14. It's still a polynomial. It's a polynomial of degree 0, and it's a constant. The next degree we have is 1. It's linear. So that means I do have an x value, right? My x value, the exponent is technically 1 here, and that's what makes it linear. And that's what we dealt with at the beginning of the year. When we graph it, it should create a straight line. So here's a really good example of a linear function. Second one is a quadratic. That was our whole last unit, right? And a quadratic has something with an x squared value. So here's a good example of an x squared function. This is a quadratic function with a degree of 2. Now notice the degree has to do with the exponent, right? Here there was no x, so we had a degree of 0. Here we have an x to the first power, so it's the degree of 1. That's the highest exponent. Here we have one with an x squared and an x to the first power, but the degree goes with the highest exponent for the term with the highest exponent. Excuse me. Okay, so we're going down. We've got 3 now. This is a cubic. It means we have an x cubed value. That's our highest term. 4, quartic. We have an x to the 4th value. That's our highest term. So now you have this lovely chart so that when you do this next problem, you can come back and refer to it to figure out what your degree and type would be. So let's take a look. So it says, identifying polynomial functions. Decide if the function is a polynomial. If so, write it in standard form. State the degree, type, leading coefficient, and the constant. Okay, so we're going to take a look at this one. We're going to look at we have to think about our definition of polynomial, and then we can write out all those things we learned from that chart: degree, type, leading coefficient, and constant. So the definition of a polynomial function is that the exponent has to be a whole number and positive, and that all of the coefficients have to be real. Well, looking at the coefficients, they're both real. There's no i's. They're not imaginary, so we're good there. So the next thing I'm going to look at is my exponent. So here I've got a 1/2. Well, right away, that's boom, 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 not a polynomial because it's not a whole number. So right away, I can just go ahead and say no, not a polynomial, and I don't have to do the rest of what they're asking for me. Okay, let's move on to the next problem. So here I have -8 to the x to the 5th power minus 4x squared plus the square root of 10 plus x to the 4th power. So I have to do the same thing. I'm going to use my definition. Number 1, do I have all real coefficients? So coefficients are what is multiplied in front of your variable. So that's real. That's real. This one has no variable. And this one has a 1, so that's real. So that's okay. The next thing says, for all of your variable terms, are the exponents whole and positive numbers? Well, here's my x term. This is 5, that's whole and positive. Here we have 2, that's whole and positive. This one doesn't have an x, so I don't have to worry about it. And this one is actually also whole and positive. So this is a polynomial. The tricky part about this one is people look at the square root of 10 and they say, oh, not a polynomial. Well, there's no x value here, so we really don't care that there's a square root over that. It's only when that square root goes over our x, because then it becomes a non-whole number exponent. Okay, so standard form. Remember, when we write things in standard form, we have to go from highest degree, or the highest exponent term, to the lowest degree. So I'm going to go ahead and start. I've got 5, 4, 2, 0. So that's the way I want to do that. I want to go ahead and say, okay, this is g of x equals -8 x to the 5th power. That's my highest degree. And then I'm going to go plus x to the 4th. That's my next highest. And then I'm going to go -4x squared. And then the plus square root of 10. So now I've put this one in standard form. Highest degree, 5, 4, 2, and then 0. Okay. Once I put it in standard form, it's pretty easy to answer the other questions. The degree is the highest degree term, which I always have to put first in standard form. So my degree here is 5. The type, well, I'm going to have to go back to that chart and take a look at that type. Oh, degree of 5, oh my gosh. They didn't tell us what a degree 5 was on this chart. So let's write it in. A degree of 5 is a quintic. Quintic. Or quintic. And we can use an example here, right? F of x equals x to the 5th plus 2x to the 4th minus 5. As long as it has a degree 5, it is a quintic or a quintic. I'm not sure how you pronounce it. Okay, so then we go back here. Our type is a quintic. Quintic. The leading coefficient is the number in front of the x to the fifth. The leading coefficient is -8. And our constant is our last term without the x, and x as an x value, so no x term. So here we do have a constant, and it is square root of 10. You may not always have a constant. I'm pretty sure this is quintic, just so we know. Okay. Anyway, moving on. I would like you to please try the next two on your own. Okay? Whoops. So what I'm going to do is try the next one, and then we're going to pause the video here, and then I'll show you the answer. You can check your answer. We're going to do that for the next two, and then we'll move over to the back page. Okay, so let's go ahead and check our answer here. For this one, you should have gotten yes. The standard form would be x cubed minus 4/5 x squared minus 1. Its degree is 3. It's cubic. It has a leading coefficient of 1, and it's a constant of -1. Okay, pause the video again here. Try the next one. Okay, let's take a look at the answer. The next one is no. It has a negative power on x. Let's take a look at that. See that right here? Negative power on x, which means we cannot, it is not polynomial. It does not satisfy the definition of a polynomial. Okay, let's go ahead and turn the page over, and we'll be talking about evaluating by direct substitution. So evaluating by direct substitution is really, you've been doing this forever. You've been doing it on your mental math quizzes. You've been doing it in previous ones. Now we're just dealing with higher powers. What we want to do here is plug in x into our function and evaluate. So here I have the function f of x equals -3x cubed plus x squared minus 12x minus 5. And I'm going to plug in the x to be 2. So I'm going to go ahead and do that. F of 2 equals -3 2 square cubed plus 2 squared minus 12 times 2 minus 5. Notice that whenever I plug things in, I always plug them in parentheses, and I'm going to always do that if I do that in my calculator, especially if I have a negative number. Okay? So I'm going to go ahead and evaluate. So let's remember that f of 2, right, that's just a label. It's just saying when I evaluate this function for 2. So here, I'm going to do all my powers first. Here I'll have -3. 2 to the third power is 8. 2 squared, I know, is 4. And then I'm going to leave this and do that on the next line. Okay, now that I've evaluated my powers, I'm going to go ahead and multiply. -3 times 8, that's -24, plus 4. -2 times 2 is -24. And then here I have minus 5. So I could use my calculator if I wanted. I could use my brain power. Say -24 plus 4, that's -20. Minus 24, that's -44. Minus 5, that's -49. So again, you're going to just plug in the 2 and evaluate on the side of the function. I would recommend, if you're going to try to use your calculator, to do it in small chunks. Do each term individually in your calculator, which would get you down to here, and then add that all together. Don't try to just plug everything into your calculator at once, because it gives you more room to make mistakes. Okay? And I'd like you to show your work, so that would be great. Okay, again, just like we did the last one, there's 2 more problems here. I want you to try them on your own. We're going to pause the video here. When most people are ready, we'll press play and we'll check our answer. Okay, here is the answer to the next problem. We plugged in our 3. We evaluate. We get 23. So take time to check your answer. If you made a mistake, can you see where you made the mistake? And that's why it's so important to show your work and trying not to use your calculator just all for the whole thing, because it makes it easier to see where your mistake was. Okay, try the next problem, press pause, and we'll check the answer in a second. Okay, last problem. We're evaluating here, -2. This is where it's so important to make sure you use parentheses with your calculator, right? Because otherwise those order of operations is done incorrectly. Here, we should get 5. If you have any questions, I'll be here tomorrow. Come see me. I'm available during 1, 3, 8, 10. Okay? And if you have any questions, I'll also be available after school if you want to go over it with me then. So, you do have homework. It's in the book. It is page 341. Number 1 and 3 through 14 all. Shouldn't take you very long. Make sure that you get a start on it right now if you have some time. Okay, have a great day.